So we're going to look at the exponent rules and when to use them and how to use them. So off to the left side of the screen, we can see our different exponent rules. Most of them are here. There's technically 2 that aren't there, but we'll address some of those throughout this video. So going from the top, we can see the product rule, which we use when we're multiplying, the quotient rule, which we use when we're dividing, the power rule, which is when we have a power raised to another power via parentheses, as well as 2 variations of the power rule, which we use when there's multiplication or divisioning happening inside the parentheses. So we're going to look through 6 different examples and practice selecting which rule we want and then how to use it. So let's start with the one at the top left, 4x to the third times 2x to the third. So I can see right here that I've got multiplication happening. So that's telling me that the product rule is the rule that I'm going to want to be using in this problem. Now, one thing that I'm going to do here is I'm going to go ahead and rewrite 4 as 2 to the second power. Is that something that's required to do? Not necessarily, but because I can see this 2 over here, I'm going to go ahead and do it as well. So now I've rewritten the problem as 2 squared x to the third times 2x to the third. Now, the thing about multiplication is that it's commutative. That means that its order can change. 2 times 3 is the same as 3 times 2. So similarly, I can change the order to regroup it so that my 2's are together and my x's are together. So I'm going to rewrite it as 2 squared times 2 times x to the third times x to the third. I'm also going to go ahead and regroup it with some parentheses because multiplication is also associative, which means that we can group it however we like. Now, using my product rule, what this is saying over here is that when I have 2 things with the same base, I can multiply them by adding their exponents. So that's what I'm going to do. 2 squared times 2 is the same as 2 squared times 2 to the first power. So I'm going to keep that base and add the exponents. Same thing with the x's. Both of these have the same base, so I'm going to keep that base and add the exponents. 3 plus 3 is 6. So this expression up here is best written as 2 to the third times x to the 6th power. Let's look at the next one over. So that one says x to the 4th divided by x to the 7th. So because I have division, I know that I'm going to use the quotient rule, which says that when I'm dividing 2 things with the same base, as shown over here as x's, then I'm going to subtract their exponents, the exponent of the numerator minus the exponent of the denominator. So in this problem, I can see that my bases are both x, so I'm going to keep my base and subtract my exponents, numerator minus denominator, so 4 minus 7. I know that 4 minus 7 is the same thing as 4 plus negative 7, which is the same thing as negative 3. So I can write this as x to the negative 3rd power. Now, something that we showed this year through a few different investigations and patterns was that a negative exponent, this is one of the rules that we're missing, is the same thing as dividing by that same variable with that same positive exponent. So I can rewrite this statement even better. X to the negative 3rd power is the same thing as 1 divided by x to the positive 3rd power. And that is going to be my best answer here because I have as few bases as possible with no negative exponents going on. We don't really worry about the 1 being there as a base because we always think of there being an invisible 1 multiplied by any number or dividing any number, so we don't tend to worry about it. In our next one, we can see that there's some parentheses going on. So parentheses are telling me that I am going to want to be using one of these rules in here. Now, these rules are really all variations of the same thing. They're essentially saying that anytime you have an exponent outside parentheses, it gets multiplied by each of the exponents in the parentheses. In other words, it distributes in. So in this problem, this 4 is going to distribute to both the x and the y. Now I notice here that the y doesn't have an exponent, so I can actually rewrite it as y to the 1st power. So when I distribute that exponent in, I'm going to do 4 times 2, which gives me x to the 8th, and 4 times 1 gives me y to the 4th power as the best way that I can rewrite that statement. Continuing on, going to the next one. I can see that there's some multiplication going on, x to the 5th times y to the 6th, and x times y squared, but neither of those are like bases. So that means that I'm not going to be able to use my product rule in this problem. However, I do have this division, and I do have like bases. So what I'm going to do is I'm going to rewrite the problem, breaking it up into pieces as x to the 5th over x times y to the 6th over y squared. I'm going to go ahead and change that to a dot multiplication so that it doesn't look like another x. Now that I've broken up, it's now following the model of the quotient rule, which means that I can go ahead and use that. I'm going to subtract my exponents and keep my base. You can see that this x here doesn't have an exponent, so I'm going to give it the invisible 1, because an x is the same thing as 1x. So using my quotient rule, I'm going to keep my base and subtract my exponents. And same thing with the y's, keep my base and subtract my exponents, which means that this expression can be rewritten as x to the 4th power times y to the 4th power. Continuing on to our last two problems. This one I can see is going to be an application of this rule right here, where that exponent on the outside is going to distribute to each of those exponents on the inside. A really common mistake is seeing I've got this -2 and I'm going to distribute it to this 2. So doing 2 times -2 is -4. The problem here is that it's not actually distributing to the 2, it's distributing to the exponent of the 2. So what I'm going to do is I'm going to go ahead and rewrite it so that I have 2 to the 1st power so that I can make sure that I'm avoiding that mistake. So now when I distribute that exponent, I'm going to do -2 times 1, -2 times 3, and -2 times -3. So I can rewrite this now as 2 to the -2, x to the -6, y to the +6. I'm going to go ahead and move down the page just so I can have a little more space on this problem, but I'll keep your properties visible on the left-hand side. So using my negative exponent rule, I know that the 2 and the x both need to move because they both have a negative exponent. The y is happy where it is. It has a positive exponent, so it doesn't need to move. So my y to the 6 is going to stay in my numerator, while my 2's and my x's are going to move to the denominator. When they move to the denominator, their exponents become positive. So this expression is best written like this, or if I wanted to evaluate the 2 squared, I could rewrite it as y to the 6th over 4 x to the 6th. And for our last problem, this one we're going to use a few different rules as well. I can see right here that there's parentheses. However, I don't see any exponents on the outside of that parentheses. So really there's a 1 there. Now, when I distribute a 1, 1 times any exponent is just going to leave that exponent the same. So really these parentheses actually aren't doing anything here. So I'm just going to rewrite it without those those parentheses. 5x squared y times 2x to the 4th y to the -3. So now really all that I have here is I've got multiplication telling me that I'm going to be using the product rule up here. So just like we did before with the product rule, we're going to regroup it so that our like bases are together. My 5 and my 2 don't have any exponents, so I'm going to go ahead and group those together as just normal multiplication, 5 times 2. I'm going to continue going, regrouping x squared with x to the 4th, and y with y to the -3rd. And I'm going to go ahead and stick an invisible 1 exponent on that y because we know that it's there. Remember, it was okay for me to rearrange this and regroup it because multiplication is both commutative, meaning order doesn't matter, and associative, meaning that grouping doesn't matter. As long as it's all multiplication, it's okay for us to do this. So now I can evaluate that 5 times 2 is 10. X squared times x to the 4th, keep the base and add the exponents, gives me x to the, not the 4th, to the 6th power. And y to the negative 1, y to the 1 times y to the negative 3, adding those exponents and keeping my base gives me y to the negative 2. So I'm almost done. I can just make this answer even better by realizing that this has a negative exponent, which means it wants to move to the denominator. So I can rewrite this as 10x to the 6th divided by y squared. Thank you all for watching.